Hi everyone, I'll speak about the effects of shape and functional groups of nanogold on the metabolomic responses in Daphnia magna. The release of nanomaterials into the environment has a potential harmful effects on the aquatic ecosystem. However, there's still limited information regarding harmful effects of these nanomaterials, especially at the molecular level. Nanogold have been developed for applications in biomedical fields, for imaging, and as a drug delivery vector. This is to ensure effective dispersion of nanomaterials in biological media. The materials are manufactured in different shapes and have different functional groups attached. Nanogolds are materials with a size range between 1 to 100 nanometers. Daphnia magna are planktonic crustaceans and are mostly used model species due to their ecological importance in the aquatic ecosystem. These species are important primary consumer at base of many aquatic food webs. The aim of the study was to determine whether ionic gold compared to two different types of nanogold altered the metabolomic profile in these species, similarly at the same lethal concentrations. The objective was to determine LC10, 20, and 50 of nanogold and ionic gold to these species, and then was further to perform exposures at both LC10 and 20 for metabolomic profile. An acute toxicity test was conducted following an OECD 202 protocol. Briefly, 3 replicates of 7 Daphnia per beaker was tested across an increasing range of concentration for a period of 48 hours. This was done for all treatment groups listed below. After 48 hours, the data was analyzed using ToxTrack software. This was to determine LC10, 20, and 50 for all treatment groups. For sublethal exposure test, briefly, 10 replicates of 10 Daphnia per beaker was tested for LC10 and 20 for a period of 48 hours for all treatment groups, including the control. After 48 hours, Daphnia was placed in an Eppendorf, flash frozen with liquid nitrogen. Samples were kept at minus 80 degrees. The samples were taken for further metabolite extraction. The equipment used was GCMS. Data was analyzed using MetaboAnalyst, normalization by median, and autoscaling. ANOVA statistical significance was stated where P was less than 0.5. For pathway analysis, normalized by median and autoscaling, the library pathway used was common fruit fly. During ionic gold, in ANOVA, metabolite 3 showed a significant increase, whereas the rest of the metabolite showed a significant decrease when compared to the control. PLSDA diagram indicated an overlap between LC10 and 20. I will only show one pathway analysis and the most affected metabolite in the highlighted pathway due to time limited. During LC10 ionic gold, niacinamide showed a significant decrease when compared to the control in this pathway. Niacinamide can cause seizures. During LC20 ionic gold, arachidonic acid showed a significant decrease when compared to the control during this pathway. Arachidonic acid is crucial for reproduction and potentially an environmental sex determination in Daphnia magna by increasing female reproduction. During citrate capped metabolite 3 showed significant increase, whereas the rest of the metabolite showed a significant decrease when compared to the control. The PLSDA diagram showed separation of LC20 from the control. During LC10, citrate capped aspartic acid showed a significant decrease when compared to the control during this pathway analysis. Aspartic acid can cause schizophrenia. During LC20, cholesterol showed a significant decrease when compared to the control during the highlighted pathway. Cholesterol can cause cardiac disorders, for instance, heart disease. During CTAP rod shape, in ANOVA, metabolite 2 and 5 showed a significant increase, whereas the rest of the metabolite showed a significant decrease when compared to the control. PLSDA diagram showed separation of LC20 from the control and overlap between LC10 and 20. Serine showed, during LC10, serine showed significant decrease when compared to the control during the highlighted pathway. During LC20 CTAP, niacinamide showed a significant decrease when compared to the control. Niacinamide can cause leukemia. Niacinamide can cause kidney disease, whereas on the previous slide, serine can cause leukemia. During LC10, metabolite 4 showed a statistical significance. Metabolite 1 and 3 showed increased significance, whereas metabolite 3, 5, and 6 showed a decreased significance when compared to the control. The PLSDA diagram showed an overlap between treatment groups at LC10. During LC20, metabolite 2 and 5 showed a significant increase, whereas the rest of the metabolite showed a significant decrease when compared to the control. On the other hand, the PLSDA diagram showed distinct overlap between LC20 treatment groups. In conclusion, ionic gold found to be highly toxic when compared to the CTAP rod-shaped, and citrate capped was less sensitive to gold nanomaterials. There was metabolite overlap between LC10 ionic and LC20 CTAB rod-shaped. That is, niacinamide decreased in the following pathway, indicating oxidative stress, rerouting of carbon sources used for energy, change in energy metabolism in response to a stressor. Furthermore, citrate-capped LC20 ionic gold and LC10 CTAB rod-shaped had different metabolite responses. Therefore, there is specific nano and ionic stress response. Thank you.